Good morning. This is lesson module 2 and lesson 4. So there are only 5 lessons. You're getting really close to the end. Let's say this together, starting here with the know. Know and relate metric units to place value units in order to express measurements in different units. So we're going to be comparing and looking at all of these metric units that we've learned, and we're going to be looking at them and putting them on place value charts and seeing if that helps, again, further increase your understanding of them. All right, our application problem. Adam poured 1 liter, 460 milliliters of water into a beaker. Remember, the beaker is the glass tube thing that we were looking at a couple of days ago. Over 3 days, some of the water evaporated. On the 4th day, 979 milliliters of water remained in the beaker. How much water evaporated? So what do we know? We know what he started with, so we know his original amount, so that would have been his total. And we know that some of the water evaporated, and we know that this much was left. So let's make a tape diagram. Remember, we'll start with our total, which we do know, which was 1 liter, 460 milliliters. And we know that at the end, he was left with 979 milliliters. What we don't know is how much of that evaporated over the 3 days. So this is, as we look at it, we know our total, we know a part of the another part, so that tells us that we're going to be subtracting. I'm looking at this and thinking that I'm going to go ahead and put it, I think the simplest way would be to put it all into the same measurement. So rather than doing 1 liter, 460 milliliters, I'm going to put it all into milliliters. So 1 liter I know is 1,000 milliliters, right? So I know I can go ahead and start with that. So I've got 1,000 milliliters plus the 460 milliliters that's already a part of this equation. So I'm going to start off with 1,460 milliliters, and I'm going to subtract 979 milliliters. And this way it becomes a simple subtraction problem. I can see that I'm going to have to regroup to make this a 10, and this will be 5. I won't have enough there. I'm going to have to regroup here and turn this into a 3 and this into 15, and then take here and we'll end up with our 13 here. 10 minus 9 is 1, 15 minus 7 is 8, and 13 minus 9 is 4. So again, remember that we can check that by just going over right here and adding these two bottom numbers to see if we get our top number. 9 and 1 is 10, 1 and 8 is 9, and 7 is 16, plus 1 is 10, and 4 is 14. And this was where we started, so I know that my answer here of 481 milliliters is correct. All right. Again, I went right into that without giving you much chance to pause, but I do want you to try things on your own. So we're going to look at this and remember what our units are equal to. So 1 liter is 1,000 milliliters, right? 1 kilometer is 1,000 meters, and 1 kilogram, shouldn't say kilogram here, it should say gram, is 1,000 grams. All right, hopefully that was something you already knew, and just a quick review there. So I want you to think about patterns of time as much as among units of length, mass, capacity, and place value. So we're going to be looking at this, so just using again that this is a tool where we can add different things, and so that's what this is going to be about here. So I want you to right now be thinking about all of the units that we have learned for measuring length, mass, capacity, and place value as well. So length, we're going to start off with, and we can measure that in meters. 1 meter is how many centimeters? You should already have been thinking this as you looked at it. That's 100 centimeters, right? So when we measure mass, so 1 meter, if we relate it to our place value, I'm sorry, I'm kind of talking. 1 meter is 100 centimeters. 100 ones is equal to what? 100, right? Okay. How about 1,000 ones? It's equal to 1,000. And we already know that the 100 ones was equal to 100. All right. Now, length. We've measured length, and we measured length in meters. So now we're measuring capacity. How much does something hold? And that's what that means, capacity. So we know that 1,200 milliliters is 1 liter, 200 milliliters, because 1 liter is equal to 1,000 milliliters. There's a spelling there for you if you ever need to have that rather than the abbreviation. So let's look at this. We've got 15,400 milliliters. We are going to compare that to 15,000 milliliters. Remember that 1,000 milliliters is equal to 1 liter. So if you've got 15,450 milliliters, then that means that 15,000 there can become liters, because 15 times 1,000 is 15. And then we have the 450 milliliters left over. We can take that same number and say 15,450 kilograms, which is a measurement of mass, or we think of sometimes with weight. They're similar, but not exactly the same. Let's look at this next problem. I think we have a typo here. We've got 15,450, not kilograms, but 450 grams. So now we're going to put that into kilograms and grams. This will be similar to what we just did with our liters and milliliters. We know that 1 kilogram is equal to 1,000 grams. So if we have 15,450 grams, we can take that 15,000 grams and turn it into 15 kilograms, and then we're left with the 450 grams. So if you look at the two here, you can see the similarities there. So we can do the same thing, comparing it if we were doing it on a place value chart. We could say that 15,450 ones is equivalent to 15 thousands, right? 450 ones. And that's how we could compare all of those to those things that we know about place value, which we've been studying actually all year. All right, let's look at what we know about this right here, 895 centimeters. Well, what do we know about centimeters in their relationship to meters? We know that 1 meter is equal to 100 centimeters, right? So if we have 800 centimeters, we could say that we have 8 meters, 95 centimeters. If we were going to put that on a place value chart, we could look at 895 ones is 8 hundreds, 95 ones. So you can see, again, there's sort of this relationship that we could figure out how to put that onto a chart. All right, let's look at this and try to compare these units, putting them onto what is very similar to basically a place value chart. So we've got 1 milliliter, 10 milliliters, 100 milliliters, and then we went to 1 liter. Why did we do that? Because 1 liter is equal to 1,000 milliliters, right? So we could go with that there. 10 liters would be equal to 10,000 milliliters, because that would be 10 times 1,000. And 100 liters would be the equivalent to 100,000 milliliters, just so that you know where we are. So if we're going to take this and we're going to take 724,706 milliliters. So let's figure out where we're going to put that. 700,000 would go here under our 100 liters, right? 100,000 milliliters would be similar. And we would put the 2 into our 10,000, the 4 into our thousands. Then 100 milliliters would be 7. We don't have anything. We don't have any tens. So we'll just put a 0 there. And this 6 would go into the ones of our milliliters. This is how we would write this in a chart. Now we're going to compare that to 72 liters, 760 milliliters. So this is in a different format, right? So we've got in our tens of liters, which is right here, we're going to put our 7. And we have 2 in our ones right here. So we'll put our 2 here. And then we'll put our 760 here. So looking at it on this chart like this, right away you can tell that our first number, 724,706 milliliters, is greater than our 72 liters, 760 milliliters. We could also have figured that out by putting that, if we chose to put our second number into all milliliters, then we would have 72 times 1,000, which would be 72,760 milliliters. So that's how that would work. All right, so we can compare metric units using our place value and a number line. We can just go ahead and say we put kilometers on the top, and then we put centimeters or 0 meters on the bottom. 1 kilometer is equal to 1,000 meters. 2 kilometers would be 2,000 meters. And 0 centimeters would always be there, all at 0 on that. So that's how we could put things into kilometers. We could also, if we remember well, 1,000 meters would be times 100 to get it into centimeters. So we would have to add 2 zeros to that. So we'd have our 3 zeros plus our 2 zeros, and then we'd put in our others. So we'd have 100,000 and 200,000 centimeters. And we could then place numbers onto that where we in the appropriate places. So let's just let's look at the next one, and we're doing the same thing. We've got our number line, and we've got meters on the top on this one, and we've got kilometers, and meters on the bottom. And we're going to try and place 7,256 meters. So we have to figure out, well, where is that going to go? 7,256 meters. I want you to go ahead and pause, draw this on your board, figure out where you would put that. Turn this back on when you're done, and you can see that 7,256 meters would fall somewhere between 7,250 and 7,260 meters. So we're going to put it approximately right here. And since we're writing in meters, we'll just go ahead and keep it up there where it is. You can label it top or bottom, it doesn't matter. We have a very similar 7 kilometers, 246 meters. And again, we can see that that's going to fall between these two. So we'll go ahead and put that one in. 7,246 meters. And then we have 725,900 centimeters. This is in centimeters. So remember that centimeters are 100 times, 1 meter is 100 centimeters. So if we want to put this into meters, then we're going to get rid of those 2 zeros there. And we have 7,259 meters. So that would go right here. I don't really have room to label that. But that would be our 725,900 centimeters. So I'll just label it right under here. All right, you have come to time to do your problem set. So good luck with that, and hopefully you understood this. If you have questions, hopefully it would help you to go back and review, then you can do that.